NVIDIA Blackwell Performance Analysis. Welcome to our deep dive analysis of NVIDIA's Blackwell architecture and its groundbreaking performance in the semi-analysis Inference Max benchmarks. What we're seeing today isn't just another incremental GPU improvement. This is a fundamental architectural leap that's redefining what's possible in AI inference. The numbers we're about to explore show performance gains that translate directly into competitive advantages and substantial cost savings for enterprise AI deployments. Benchmark Overview. Let's start with the hard numbers from semi-analysis's comprehensive testing. For LLMA2 70B inference, Blackwell delivers a staggering 3.7 times the performance of the previous generation H100. When we look at GPT 3.5 scale workloads, we're seeing 2.9 times more tokens per second. But perhaps most impressively, for mixture of expert models, Blackwell achieves 4.1 times the throughput. The performance per watt story is equally compelling. Blackwell delivers 4.2 times more performance per watt than the H100. These aren't just benchmark numbers. They represent real-world cost savings and efficiency gains that will impact every enterprise running AI inference at scale. Architecture advantages. So what's driving these massive improvements? Blackwell introduces several key architectural breakthroughs. The second-generation transformer engine brings dynamic precision scaling with new FP4 and FP6 formats, optimizing every operation for maximum performance per watt. Fifth-generation NVLink provides 1.8 terabytes of interconnect bandwidth, enabling seamless multi-GPU scaling that was previously impossible. The unified memory architecture with 192 gigabytes of HBM3E memory delivers both capacity and bandwidth, while the dedicated decompression engine provides hardware acceleration for sparse model execution. These innovations work together to create a platform that's fundamentally more efficient than anything we've seen before. Competitive landscape. When we compare Blackwell head-to-head against the competition, the advantages become even clearer. For LLMA2 70B inference, Blackwell delivers 142 tokens per second compared to 89 for AMD's MI300X and 67 for Intel's Gaudi 3. In power efficiency, Blackwell's 4.2 tokens per watt dwarfs the competition at 2.8 and 2.1 respectively. Memory bandwidth tells a similar story, 8 terabytes per second versus 5.3 and 3.7. And when we look at FP8 performance, Blackwell's 9,728 teraflops is nearly double AMD's offering and almost triple Intel's. Across every metric that matters for AI inference, Blackwell establishes a new performance baseline that competitors will struggle to match. Enterprise ROI analysis. Now let's translate these performance advantages into business economics. While Blackwell carries a higher upfront cost at $45,000 per unit compared to $32,000 for AMD and $28,000 for Intel, the total cost of ownership story reveals the true value. Over 3 years, power costs tell a different story, $18,900 for Blackwell versus $25,200 for AMD and $28,400 for Intel. When we factor in infrastructure and cooling, the total 3-year TCO becomes $75,900 for Blackwell, actually very competitive with $72,300 for AMD and $74,400 for Intel. But the real story is in tokens per dollar. Blackwell delivers 4.2 million tokens per dollar versus 2.8 for AMD and 2.1 for Intel. For large language model workloads, Blackwell achieves 85% ROI compared to 65% for the competition. Real-world deployment. Beyond the raw performance numbers, Blackwell offers significant operational advantages in real-world deployments. The 40% higher compute density means you can achieve more inference capacity in the same physical footprint, reducing data center costs. The power efficiency improvements enable deployment in power-constrained environments where competitors simply can't operate. But perhaps most importantly, NVIDIA's mature software ecosystem with full CUDA and TensorRT support means faster time to production and more reliable operation. Our deployment timeline analysis shows Blackwell reaching production readiness in half the time of competitive solutions with comprehensive monitoring and management tools that enterprises rely on for mission-critical AI workloads. Future outlook. Looking ahead, the Blackwell advantage is only going to grow. We expect to see initial deployment in hyperscale data centers throughout 2024, with mainstream enterprise adoption accelerating in 2025. By 2026, we project NVIDIA will capture 72% of the AI inference market, which is expected to grow to $280 billion by 2027. The competitive response timeline shows AMD and Intel struggling to catch up, with their next-generation solutions not expected to match Blackwell's performance until late 2025 at the earliest. This gives NVIDIA a significant window of market dominance that enterprises should factor into their strategic planning. Conclusion. In conclusion, the data is clear and compelling. Blackwell's 3.7x performance improvement over previous generations, combined with 4.2x better power efficiency, represents a fundamental shift in AI inference economics. The 85% ROI for large language model workloads makes Blackwell not just a technological upgrade, but a strategic business investment. Our recommendations are straightforward. Evaluate Blackwell for all new AI inference deployments, plan infrastructure upgrades to leverage its power efficiency, train teams on Blackwell-specific optimizations, and budget for deployments in Q4 2024 and Q1 2025. For enterprises serious about AI competitiveness, Blackwell isn't an option, it's the new standard that will define the next era of AI infrastructure.